Hello, I'm Francis Nedvidek, Principal Technology Analyst at AutoSens Research. You're watching AutoSens Insights. Today, we are speaking with Boyd Fowler, Chief Technology Officer at OmniVision Technologies. Hello, Boyd.
Hello, Francis. Thank you very much for having me today.
Great to have you. I'm glad we could get this occasion sorted out and we can have a little bit of a chat. So Boyd, today I'd like to review a little bit about the progress that OmniVision has seen in the recent time. And one of the major things that strikes me when knowing about your company and hearing from others is that you are tackling this immense explosion of performance, reduced power consumption, better everything, more of everything. How are you doing it? Your company seems to have that in grip.
There are many different aspects many different things that we do to try to address this. Now, again, we're positioned in a very good place for this growth at the moment. Not only do we build sensors for automotive, but we build them for the mobile platforms, we build them for security, we build them for medical, we build sensors for many, many applications. And as we develop technologies in all of these different areas, we can put them into automotive products. And so I think that's positioned us very, very well as the number of image sensors in cars has grown and the complexity as well as the diversity of types of image sensors has. So if you look at things like in-cabin monitoring and you look at the requirement for near-infrared sensitivity, well, we developed a technology called Nixel that was initially used in security applications, but we were able to move into automotive. The same thing is true for things like global shutter. First, that was developed for things like AR, VR, for other types of applications, but now it's moving into automotive. And so we take a lot of the technologies, even small pixels from mobile, we use that technology to improve the performance of our pixels in automotive.
And so do you see in these terms, the cabin monitoring as becoming a standard option or maybe mandatory going forward?
We do see that in the industry right now. We see that more and more interest in cabin monitoring. People are very interested in watching what the driver does to make sure if someone's being drowsy or if something's happening in the back seat. So actually, even the driver can monitor their children in the back. So driver monitoring is not only the driver, but often the passengers at the same time. And this is very interesting to most of the OEMs out there, and clearly there's growing interest in this area, likely something that you'll see in cars very, very soon.
You mentioned backside illuminated global shutter, and this is a technology that you now, from other areas, have adapted or adopted for cabin monitoring.
Right.
What comes next? What's the next gen of this technology or this update for you?
So what's happening for us is a couple key things. One thing that we're doing is we're reducing the pixel size. And so therefore we're allowed to make them smaller and be able to hide them in places so it's very hard to see them. And this enables us to use things, it allows us to not only reduce the size, but also because of stacking, we can actually add additional functionality, and things like high dynamic range is another thing that typically has not been in global shutter sensors, but this is what our next generation is going for. So we're going to be able to have good near infrared sensitivity, very small form factor so it can fit anywhere, and at the same time, high dynamic range.
So again, you brought up another thing where you're a leader, this 3-layer stacking, as you call it. It seems to me, as I understand it, maybe you can explain it better, you have a lot of competing parameters when you're trying to design a camera with high performance, low power consumption, small footprint, quick response, good infrared, good visible. Can you illuminate that a little more? No pun intended.
Love to talk about that. So, 3-wafer stacking, 2-wafer stacking, the idea of stacking is relatively simple. What we want to do is we want to make sure that the size of the die itself is limited by the number of pixels. So that's obviously as small as we can physically make it. But another thing that's very important in stacking is that often the technology that you need to build the best pixels so that you can get high quantum efficiency, high modulation transfer function, very low read noise, high full capacity is not the same process that's really good for digital logic, and may also not be the same process that's the best for analog readout. And if you build something like a 3-wafer stack, we can optimize each layer for the type of functionality. So you imagine the top are pixels, in between maybe your analog readout, and then at the bottom is all of our digital. And we can pick the most aggressive process for the digital so that we can have very low power dissipation. We can pick a very low noise kind of mix mode process for the middle wafer for doing analog. And on top, we can have an optimized process specifically for collecting photons.
And you were one of the first to introduce this capability to handle flickering LEDs or lights that are changing intensity and causing problems with images and detection. What's next there? You're going to obviously have some ideas with all these advances. Something's going to give there as well.
Yeah, let's talk a little bit about that. I think that's a great question. So LED flicker mitigation is a big issue in the industry. And just to kind of clarify what it all is that most signage nowadays is using LEDs, and it doesn't matter if you're in Europe, the US, or in Asia. And because of that, the LEDs typically are pulse width modulated, and that's to extend their life and also to control their intensity. But unfortunately, the period at which they pulse is not always the same as the capture period that the image sensor sees, because it uses rolling shutter. And so therefore, sometimes the LEDs look like they're on, sometimes they look like they're off. And this causes problems both for human vision. You could imagine a policeman behind you and you think their lights are flashing where they're not. And then you pull over, obviously not something you want to have to happen. But at the same time, for machine vision, it can be even worse because it may misread signs. It may misread what's going on in the scene and do the wrong thing. And clearly that could be significantly worse. So LED flicker mitigation is really required nowadays for almost all sensors outside of the cabin. And what we've been doing is we've been trying to develop technologies that enable us to have very wide dynamic range, like 140 dB, at the same time as having LED flicker mitigation. And this is a very, very challenging task because, again, to do this, it's very hard over a very wide range of external illuminations as well as LED frequencies. And so as we look at all these parameters, we've been spending a lot of effort developing LFM, and specifically LFM in high dynamic range applications. And our newest products, this is what we're really trying to bring to market.
Okay, very good. A clear answer. So that begs the question, if you can do this with the flashing lights, what happens in a normal imaging situation when you have oncoming traffic lights, you have glare on a wet road, the sun's going up and down, you go from a tunnel to the clear day. Are all of these encompassed as well and taken care of? With
Absolutely. When we look at 140 dB of dynamic range, that represents 10 million to 1 when you look at intensities. So when you're in the tunnel and you're looking out, this is something that will allow you to see outside the tunnel while you're inside. Also, in applications where you might have ice on the road and you have a lot of glare, all of these situations require wide dynamic range. And what we've been working on are sensors that have up to 140 dB of dynamic range. And that is, I think, key for a lot of external applications because of the challenges that you just talked about.
Okay, so good. That's wow, amazing. And these are standard products. These are in cars now, in automobiles, and
these products are not in cars today. These products are in sampling to customers. As we all know in the automotive business, it takes a little bit of time between when you develop a new product and before it's finally integrated into a car that you could buy if you went down to the dealership. So we're still a few years away before you'll see them in mass production in all the cars. but we have developed these sensors, and we are shipping them to OEMs right now for them to implement into systems, and we have won some deals already.
And in this value chain, do you typically, of course, it's always good to have a pull as well as a push. So if an OEM says, this is the thing I have to have, it's a really good feature, that's great. But as I understand it, most of these OEMs go to their vendors, preferred vendors, partners, and they supply modules that are plugged into the cars. So you work with both of them, or I suppose you collaborate with the top tier as well.
We work with tier ones, and we work with the final car manufacturers. And so we spend time talking to both groups, because we try to educate them on what the newest technologies are and what things. Also, at the same time, we like to hear what their problems are. You know, one of the things that happens all the time is that there's something new that happens, and when you talk to the manufacturers themselves, they often see issues that maybe even the tier ones haven't told us about yet. So we do work with both the tier ones as well as with the main car manufacturers.
And these sensors, this suite of sensors, at some point are plugged into this perception engine or brain.
Yes.
How do you interface with that? What there has to be. I'm not talking so much about the technical or the digital interfaces. There are a selection of available sensors on the market that tier ones and OEMs are looking at, and you have your sensors that have to work with some of these different parts of a platform. So how does that work? How do you collaborate in a team, or how does that?
We do. We collaborate very closely with some of the partners for all the tier ones. So, you know, as we know of machine vision, there are a few key companies that are working in this area, people like NVIDIA. And so we're very close with them, Mobileye. And so we try to talk to them on a very regular basis, find out where they're going, and we try to tune our roadmaps to make sure that our products will easily fit in with the platforms that they're developing for the tier ones.
Do you see going forward, when we talk about regulation and liability and standards simply is what we bought or have delivered, is it really performing the way we want? Is it performing consistently? What do you see in terms of testing and evaluation or standards in this field of the visual sensing, the image sensing and agglomeration processing? Do you see any kind of agreement there in the industry or developments?
I would say yes. There is some work that's going on there. There are standards committees, ISO committees that are working on developing standards for test and measurement of image sensors for automotive applications. And I think that will continue. I think that there's quite a bit of interest in the industry to try to standardize things so that when there's a measurement done by OmniVision or one of our competitors, it's easy to be able to compare the numbers. And I would say today that, you know, it's not always that easy because not everyone measures things in exactly the same way. Yeah. And so that is something that is of great interest to the tier ones.
Very good. Okay. So I think that takes care of most of the new recent announcements and the big issues alight now at OmniVision. Do you have anything that I missed or that is worthy of discussing?
There's only one last thing that I want to do. It's just kind of a plug. You know, we do have a demo session during AutoSens that will show off our next generation global shutter technology. You know, we talked about stacking, we talked about some of the Nixel technology and, you know, other things. You can kind of see this technology in a 2.2 micron pixel with the use of Nixel. And this will give you kind of an idea of what will happen for DMS in the future. And I think this is something that will be a game changer in terms of its performance. So anyone who's interested, I would recommend them to take a look at that.
Okay, great. So we'll be sure to watch that video when it's posted.
Great.
So Floyd, it's been a good talk, I think. I hope you're happy with it as well. I think our viewers will, thank you, they're very satisfied. And then on that note, I would say that thank you for attending. We look forward to seeing your video in the future. Looking forward to speaking again on these sessions with you. Okay, so for the viewers, you can have this and a lot more great AutoSens content on our AutoSens website. Go to YouTube, look for AutoSens to find us. And until next time.